Hello everyone, this is Rui PCB, your trusted PCB partner. Today we'll be introducing the commonly used commands for schematic libraries in Kit. First, we need to open the project we created last time, and then click on Schematic Library Editor. I've pinned the global library we created last time to the top. This makes it easier for us to use so we don't have to scroll down to find it every time. To pin it to the top, just right click on the schematic library and select pin to the top, and it will appear as the first item. Next, if we want to try creating a schematic library, we first need to create a new component in our existing library. Click on create new component. Here you can set the component name according to your actual needs. We'll set it as tester here. This field is for the default reference designator, which will be displayed in the schematic. As for the reference designator, there are some commonly used rules in PCB design, and these are the rules we typically follow. For example, we use R for resistors, C for capacitors, L for inductors, T for transformers, D for diodes, Q for transistors, U for ICs, and CN or CON for connectors. For light-emitting diodes or digital tubes, we use LED. For switches or buttons, we use SW. For crystals, we use Y. And for fuses, we use F. We use BZ for buzzers, K for relays, and BAT for batteries. These are the common ones. For others that are less common, you can set them according to your own habits. Now, let's say we want to create an IC here. We'll just set it as MU by default, and you generally don't need to change any of the other default options. Click OK. This way, a tester component appears on the left side. Now, regardless of the component, we always deal with pins. We may need to place an uncertain number of pins, depending on the component, for example. A resistor usually has 2, while an IC depends on its actual configuration. The first option is S's, which is the name of the pin. Generally, each pin on an IC has a specific name, and we need to write this name according to the actual situation. This way, when drawing the schematic, we can easily understand the function of each pin. Let's just write tester 1 here. Then, the pin number ICs also have sequential pin numbers. Next, here is the electrical type of the pin. The electrical type includes input, output, bidirectional, tri-state, passive, free or unspecified, power input, and power output. There are also open drain, open collector, open emitter, and not connected states. I recommend choosing according to the actual state of the pin. This way, after we finish drawing the schematic, we can check for errors and determine if there are any issues. For example, if you set the input pin as output signal, it will alert you with error, helping you avoid mistakes in the schematic. Here, let's choose a bidirectional type. The next option is the pin style, and there are many different styles available. There are options like graphic, inverted clock, input 1, clock output 1, falling edge, and non-logic. These should also be selected based on the actual parameters of your pin. For example, if this pin is a clock signal, then we select clock. This helps you check for errors when drawing the schematic. Next is the direction. The direction mainly determines which side of the component the pin is on, so you set the corresponding direction. Let's keep it on the right side. Then click OK, and here you can see we've placed a pin. Placing it here, this is how you add a pin. The number of pins you place depends on your actual needs. The second one is text. The text is mainly for making notes. For example, if the chip or pin has some special function or is prone to errors, we can add a note to this pin. This makes it easier for us to use and helps prevent mistakes. For example, this pin must be pulled down for the chip to work properly. So we can add a note indicating that this pin should be pulled down. Next is a text box. A text box is a more restricted form of text input, mainly used for special cases. Some special components might require unique labels, and the text box makes it easier for us to draw and use them. This one is for drawing a rectangle. Usually we use a rectangle to represent the outline of an IC. For example, we draw a rectangle like this and arrange the pins around the outside of the rectangle, defining it as the shape of the IC. This one is for drawing circles. Sometimes certain ICs have circular markings, and in these special cases, drawing a circle helps us create a more realistic representation. The next tool is for drawing arcs, which works in the same way, specifically 2-point arcs. Then we have the Bezier curve tool, which allows us to draw special shapes as needed, making our schematic symbols more closely resemble the real thing. This is the straight line tool, which can be used to draw one or multiple segments. After finishing, click End, and it will draw two segments. Next is the polygon tool, which also helps us more realistically recreate the schematic library of the component. This one is for setting a new anchor point, but we generally don't use it. It's better to stick with the original coordinate anchor point. This one is for deleting. If you made a mistake or don't need something, just click delete. So today we will introduce how to use the schematic library. In the next lesson, we will cover how to actually draw our components. If you enjoyed this video, please subscribe to my channel for more resources. Thank you everyone.